this is just the domain for the final product of f of g of x. The input x cannot be -2 as well, because if x is -2, you can't even plug it to g. Okay, so actually the domain for the entire composite function is x cannot be -1, and then x cannot be -2. -2 for g right here. Function inside. That's why we have 1 is okay. And let me explain to you why we need this. X cannot be -1, -2 in this case. -1 for the final composite function, and then -2 is for the domain of the function g, because we need g first before you have the composite. Okay, check it out. I need some room to write, so let me just erase this line right here. I'm gonna keep the final answer. Okay. Let's try. I claim domain is what everything except for -1 and -2. Let's see why. Try x equal to -1. What happened? We're talking about what? F of g of x, right? So first of all, you have -1. You plug into the function g. Function g say what? 1 over -1 plus 2, right? So -1 plus 2 is 1. 1 over 1 is equal to 1. This is 1. And you use 1 to plug into f. So -1 is okay with g. G say what? I will buy any x except for -2. So I'll take -1. -1 is good. I plug and I got 1 out. But when you plug -1 into g, you get 1 out. And what's wrong with 1? 1 is not okay to plug into f. That's a problem. So 1 you plug into f, you got 2 over 1 minus 1. This is undefined and not exist. See why? We don't have -1. That's the input. Now try -2. X equal to -2. See what happened? G, plug on g, right? -2. 1 over -2 plus 2. Oh boy. Plug in -2. You don't even have g to start. So you don't have a change yet. You stop right here. Right? This gives you 1 over 0. And this is 1 over 2 over 0. It's undefined. And you don't have the output for g. And therefore you will not be able to plug into f to get the final answer. And that's why you have the domain with what? X not 1, -1, x not -2. Okay. Let me keep the same example right here, but this time we calculate what? G of f of x. See how we find a domain. Okay. We do g of f of x. X now, I want this is the input to plug into f. Okay. And then whatever I have, I'm going to plug into g. So x plug into f, I got what? 2 over x minus 1. I'm going to use the whole thing as the input to plug into g. So for g is 1 over the input, which is 2 over x minus 1, and then plus 2. Okay. See, f of x is 2 over x minus 1. Now, the whole thing right here, 2 over x minus 1, becomes the input to plug into g. So 1 over 2x minus 1 and plus 2. And same way of simplifying, multiply the top and the bottom by x minus 1. X minus 1. And we have what? X minus 1 on top over 2 plus 2 times of x minus 1. Okay. 1 times x minus 1 just x minus 1. 2 over x minus 1 times x minus 2. 2 times x minus 1 is 2x minus 1. This is x minus 1 over 2 plus 2x minus 2, right? Which is x minus 1 over 2x. Now the domain of this composite function is what? All real number x. X cannot be equal to 0. And one more time, it's not enough yet. Not just x cannot equal 0. X cannot be what? In the domain of x right here, x cannot be equal to 1 as well. It's the same reasons we had before. What happened when x equal to 1? You plug 1 in here, you don't even have the output for f. And you don't have it, you cannot plug into g. And x equals 0 right here. X equals 0, it's okay to plug into f, but at the end, you have something over 0 is undefined. X cannot be equal to 0, and x cannot be equal to 1. And 0 comes from this final composite function. x cannot be equal to 1 come from domain for x, for f, I mean, because domain for the internal function, right? You have to use the output of f to plug into x. First of all, x got to satisfy the domain of f before you can calculate the composite, and that was the idea. Okay, and that was it for just one section for today. So I'm gonna stop the video clip right here, and thank you for watching, anyone. Please practice some exercises in here to master your skills. We see some algebra skills right here. Okay, be very careful with your calculation, and should you have any question, please feel free to ask. Thank you.